Hello everyone. A thin circular ring of mass capital M and a radius small letter r is rotating about its axis with an angular speed omega. Two particles having mass small letter m each are now attached at a diametrically opposite point. The angular speed of the ring will become. So you just imagine a ring is now rotating about its axis. So this is a ring and just imagine this is the axis of rotation. It is rotating with an angular velocity omega. Okay, the mass of the ring is given the capital letter M. So what is the initial moment of inertia of this body? I is equal to m into r square. It is given the r, small letter r is the radius of the ring. Now what is actually happening in the next part? Two particles having mass m each are now attached at diametrically opposite points. That means two masses, say it as here small letter m and one more mass here small letter m is attached diametrically opposite side. Now when it is started rotating, the angular velocity, say it as omega dash. What is the omega dash you have to calculate in this question? So we can directly use the conservation of angular momentum. Conservation of angular momentum. What is the conservation of angular momentum? I1 omega 1 is equal to I2 omega 2. Now from here what you have to calculate here, when the masses are attached, that means omega 2 you have to calculate. So what is omega 2? Omega 2 is equal to I1 omega 1 divided by I2. Now you can substitute the value here. What is I1? Initial moment of inertia, that is equal to m into r square. Now into omega 1. What is the initial angular velocity? That is given the omega divided by what is the final moment of inertia? I2. I2 we can write here m plus 2m, because what is the total mass here now? Mass of the ring plus these two small masses. So m plus 2m into r square. The radius is not changing here. So now you can look at this equation. R square cancel. So what is the final angular velocity? Omega 2 is equal to m into omega all divided by m plus 2m. So option B is the right answer. Thank you.